Hello everybody, and welcome back. We are looking at question 11 now, the very first question in part B on our 2016 Fermat paper. In the diagram, triangle PQR is right angled at P. And we're told that PR is 12. Oh, I see a 13. Automatically, I'm just going to fill this in as a 5 because I know my Pythagorean triples. Anyway, so PR is 12, point S is on PQ, so that SQ is 11, and SR is 13. We want to know what is the perimeter of QRS. So we've got 11, we've got 13, we just need to know this side, which happens to be the hypotenuse of this bigger right-angled triangle. Okay. So if you're like me and you immediately spotted the Pythagorean triple of 12, 13, and 5. You might immediately fill in this 5 down here. If not, of course, use the Pythagorean identity. The sum of the squares of the two legs will equal the square of the hypotenuse. So 13 squared is going to be equal to 12 squared plus this other side here. You might call it, a squared. And then you could rearrange and say a squared is 13 squared minus 12 squared. Grab your calculator if you need to. But you'll get 13 squared is 169, 12 squared 144. Their difference is 25. A squared is going to be 25, so A has to be 5. And we get this 5 down here. But it's so much faster if we recognize common side lengths for Pythagorean triangles, like 3, 4, 5, 5, 12, 13, 8, 15, 17, 9, 12, 15, that sort of a thing. Those ones are going to be very helpful because they speed up. You'll notice I was able to write down 5 as I was reading the question. Anyway, so we've also got an 11, and now that tells me this whole side is 16. And we've got a 12 over here, so we can figure out this hypotenuse here. Again, we can use the Pythagorean identity, 12 squared plus 16 squared, we might call this C, is C squared. Or again, 12, 16, and 20 is a fairly common Pythagorean triple. So you can work this out, 144 plus 256 is equal to 400, which is therefore equal to 20 squared, and realize that C is 20. That's fine. Or you could say, well, I remember 12, 16, 20. I mean, this is just a 3, 4, 5 triangle, where each side has been stretched by a common ratio of 4. Anyway, what do we want? We want the perimeter of this triangle here. So I need 20 plus 13 plus 11. 11 and 13 is 24, plus 20 is going to be 44. All right. We don't want to accidentally do the perimeter of the bigger one with the 12, the 16, and the 20, which would be 48. Okay, we want to look for 44. Oh, good, 48 isn't even a possibility, so just bubble in B. And that's the answer to question number 11. All right, so I will see you guys in the next video for question number 12. If you ever have different ways of doing questions, feel free to leave a comment down below. And, yeah, have a wonderful day.